Good evening. A warm welcome to all the participants. Before proceeding to the today's session, I would like to request Mr. V. Venkatesh, the coordinator, Assistant Professor, Department of Mechanical Engineering, to give brief introduction about the today's speaker.
Good evening, respected participants. This is Venkatesh. In the past two sessions were handled by the industrial expert as well as the research associate from CSR in New Delhi. Now, today's speaker is a different person. He is a dental surgeon, and with he will be sharing his vast experience in the use of 3D printing 3D printing technologies in resolving different problems, especially in dental industry. When it comes to a brief introduction connected to Revath sir. So Dr. Revath Vyas sir, he's a renowned dental profession based in Hyderabad. He's the founder of 3D Digital Dental Solutions, which is located in Hyderabad, a cutting-edge dental clinic known for its innovative treatment and advanced technology. With the international experience, Dr. Revath has worked in Rwanda, an East African country, where he gained a global exposure to diverse dental practices. Driven by a professional interest in emerging technologies, he has attended so many workshops which were organized by the prestigious institutes like IITs, NITs, as well as state and central government training centers. So, with this small introduction, I would like to request Revath sir to hand over to start his presentation.
Thank you, Venkat sir. Thanks for the introduction. Myself, as introduced, I'm Dr. Revath, dental assistant surgeon with master's degree in oral medicine and radiology. And my special interest or keen interest is in the complete digital dentistry. We are exclusively working on 3D technologies of scanning. I hope I am audible for it.
Yes, sir, audible, sir.
Audible, sir.
Yes. So today I would like to discuss the various topics where we actually deal with the 3D scanning technology, 3D printing technologies. Dentistry is actually the most emerging department, and it is using most of the 3D technology and digital technology and going far ahead of many other branches and departments. So with this brief intro, I just want to share the presentation. I hope my screen is clear for you all.
Yes, sir.
Okay. So as a part of this ATAL program and AICT sponsored program by Annamacharya Education Institution Trust, myself, Dr. Revath from 3D Digital Dental Solutions, want to talk something regarding 3D printing in dentistry. So thanks for this opportunity. Now coming to the areas in dentistry which are dependent on 3D technology, we use 3D technology in data acquisition. So data acquisition can be an intraoral scan where we take the scan of the patient to get all the 3D anatomy of the teeth and gums and all around it. So that is called as intraoral 3D scan. And the other scan is CT, which is similar to the CT technology. In the DICOM data, we have that 3D data, which we use in various parts of the dentistry. I will be discussing all about it in upcoming slides. So we also will be using extraoral 3D facial scans. We'll be using 3D technology in invisible aligners. I hope most of you might be knowing that Tutsi brand, who is promoting the aligners. So they are promoting the invisible aligners, which help in movement of the teeth. And the dental crowns, most of the dental crowns in the current day are being made by DMLS technology, and this DMLS technology is nothing but the 3D printing technology using laser sintering, direct metal laser sintering, and in guided implantology. We are mostly into this guided implantology part. I will be discussing more about it in the upcoming slides. So this is the intraoral scanner data. If you see this is how, when we scan the intraoral scan data, we'll be able to clearly see where is the missing teeth, how the teeth are positioned, is there any attrition or wearing of the teeth, were there any cavities. We can go through all the data. Is there any calculus stains, and is there any need for the cleaning? Everything can be assessed using this 3D data. So the same 3D data earlier was in ply format, where we can see everything in with all the shades. But when we convert it into STL format, this is how we see it. So for dental implant guide, this is the first important data we need to have. For example, for this patient, we have got a missing tooth in the first molar region. So we have got the intraoral scan data, and we have planned where exactly this implant is supposed to be coming. And we will merge this data with the 3D data acquired from the CBCT or the DICOM data. This is the DICOM data of the bone acquired using CBCT or CT scan. So implant is placed in the bone using the DICOM data, and when this DICOM data is merged with this STL data of the model, we'll be placing this properly in the bone. So this is the guide what we are talking about. When this guide sits on the front and back teeth, and when we will be drilling through this particular hole, we'll be placing implant exactly as planned. So this is the DICOM data or the 3D data acquired using CT scan. Here we will have only the data of the bone. We will not be having any data related to the soft tissues. Soft tissue data is present in the intraoral scan. So if we see the guided implantology procedure, this is the guide. It sits on the teeth, and we'll be drilling through this hole. We'll be increasing the diameter of the drill gradually. And then we'll be placing an implant there in the bone. And most of these implants are made up of titanium using 3D milling technology. And we give an attachment with very precision fit over this implant, and we give a crown over it. These crowns are fabricated either by 3D milling or 3D printing in this advanced dentistry. Earlier days, these crowns are made using human interference. Man used to make a wax pattern, then they used to cast it to get the metal, then they used to trim the metal, and then they used to add a ceramic layer over it. This has got a multiple errors, either at the time of wax pattern, making a wax pattern, or at the time of casting, or at the time of trimming. There used to be multiple errors. Now with the advent of the latest digital technology and the 3D technology, with very minimal errors, we were able to give very precise crowns. So if you see this is a case of a patient with missing upper front tooth. We have placed guide as per our design. Then this was the plan, what we are supposed to execute, and this is what is exactly executed. So we'll be drilling through this hole, placing this implant, and this is the attachment which is placed over it. And because of this precise planning, we were able to give the crown to the patient on the day of surgery itself. Such kind of precision is only possible because of the latest discovery of this all 3D scanning and 3D printing technologies. This surgical guide, what you see here, is actually 3D printed using surgical guide resin. We will be using Formlabs surgical guide resin, which is autoclavable and which is biocompatible. So this is another case. If you see, this is a radiological representation of our planning. We have thought of placing 2 implants in the upper jaw and 4 implants in the lower jaw. And this is the X-ray after execution. If you see, implants are exactly placed as they are planned. That is the advantage of precise planning, so that we can give precise executions without any errors. This is another case where the patient has got no teeth in her lower jaw. So here we have done guided placement. This is a surgical guide. When we drill through this surgical guide, we were able to place implants exactly parallel to each other within the mandible. And these are the multi-unit abutments. And over these abutments, we will be giving the crowns to the patient. This is another case. Here we have placed 4 implants. If you see the amount of trauma caused by the surgery, it is very minimal. If you see, there are only 4 holes. We need not expose it completely. And the implants are so well executed that all the implants are within the bone all around it in all 360 degrees. So see the parallel placement of the implants. This can be only possible with the surgical guides. And the patient the old denture was transferred over these abutments and was sent home with the teeth immediately after surgery. Coming to the challenges in guided implantology, here we cannot use a regular resin. We require a biocompatible resin, and this guide it is supposed to be autoclavable. So it has to tolerate temperatures up to 121 degrees centigrade, and guide has to be as clear as possible in order to see the surgical site through the guide, and it has to have good strength because we have to drill through the guide. So drilling through the guide should not cause any deformation or distortion of the guide, and it should have a good dimensional accuracy because it has to go and see over the teeth which are already present or the tissue which is already present. So in such cases, the guide has to be dimensionally very accurate. Any constriction or any dimensional inaccuracies will not give a proper fit, and finally the whole surgery will not be as per the plan. So it has to have very minimal shrinkage. But coming to the guide cost, it is somewhere costing around 10,000 to 30,000 per liter. The Formlabs resin, what I have talked already, it is costing 25,000 per liter, which is biocompatible and it is autoclavable. So we have to come up with multiple cost-effective options which can justify this being clear, being biocompatible, and being able to autoclavable. Many resins, they melt at a temperature of 60 to 70 degrees centigrade. So we are looking for a resins which are dimensionally stable, which have got better strength, and which can tolerate high degree of temperature, and they have to be biocompatible. So if we can cut down this cost of the resin, it will have a wide usage among the public. So what is the future in guided implantology? The future is already there. We are working with navigation systems. There is robotics is about to come. It is already there in US.
ప్రవీణ్ సార్ లేదు అందులోనే ఉన్నాం అందరము. సర్లేండి సార్, ఇప్పుడు మా కులీగ్ ఒక లింక్ పంపించాడు, అది క్లిక్ చేయండి సార్. ఓకే ఓకే సార్.
Yes. So coming to the advanced things, the navigation system, robotics are the latest trends in guided implantology. These two will avoid the printing of the guide. So here we can execute the same implant execution without even printing a guide. So in navigation system, it guides to precisely hold the drilling machine and help drilling precisely in a specific direction up to a specific depth. Whereas in robotics, robot will precisely drill as per the plan, and it will make our job even more easier. So at every point, we are trying to be even more precise, and we are trying to avoid complications using the advanced technology and artificial intelligence. Now coming to this is the video which shows the navigation system. So this is the X-Guide is the brand. So here the drilling handpiece has got navigation panel. Using this advanced, and it's let us know if we are going beyond the plan. This is all a computer assisted system. Here it requires the same data of CBCT and also the intraoral scan. The planning is going to be the same, but here we are avoiding the 3D printing of the guide, instead using the optical phenomenon where so now coming to the robot, this is the Yomi robot. It is already present in US. So here we have to give a specific program. Maybe you might be already dealing with multiple milling machines, which mill in all 4 different dimensions, but the only difference here is the subject will be moving. So the machine has to be so precise in such a way that it has to even act. Here they use few devices to precisely locate where the teeth are, where the implants are supposed to be planted. So this particular device will also help in real-time tracking of the patient, whether the patient is moving or whether the patient is opening and closing his mouth. That particular real-time patient movement is tracked using this Yomi link. Then the CT/CT data and intraoral data, which was earlier used for bone fabrication, is used here also. So that's or the stand data. So the planning, implant placement, depth, angulation, everything is planned in the software. So that software has got complete integration with the robot. Then comes the surgical part. Patient tracker. When the patient moves, even the handpiece moves. It will help in correction of the angulation and also correction of the position, and will help in precise placement of the implant. Still here, the dentist needs to control the handpiece. Then if you push it will stop at that particular depth. Overall, is they were able to, 1,000 implants are already placed using. Studies have already proved that it is more accurate than freehand. It is more accurate than guided and even more accurate than navigation. So this is the 3D intraoral scan data. So coming to the invisible aligner part, using the 3D technology and artificial intelligence, where the exact occlusion is supposed to be, we were able to achieve simulation or the treatment simulation. If you see here, this is the current situation of the patient, and we can, based upon the scan, using the artificial intelligence, we can find out where the treatment is going to end using the aligners. So we are supposed to close the gaps. We are supposed to achieve better occlusion using this simulation software. It's a better patient motivation and will also help in analyzing the treatment outcome. So this is how we can see how before and after the treatment, how the treatment is going to be, all ahead of the treatment plan. For this patient, there are spacings in the upper front teeth, and there is a rotated tooth. This tooth is rotated, and there are spacings here. And by the end of the treatment, all the spacings are being closed, and the rotation is also being corrected. All such kind of planning is possible only because of the 3D scanning technology. And when we talk about the pricing of these scanners, intraoral scanners, they are costing somewhere around 5 lakhs to 20 lakhs. And there are even few scanners which are costing around 50 lakhs. So most of these brands, they come from US, and low cost products, they are coming from China. India is still unable to manufacture its own intraoral 3D scanner. So we have to come up with our own technologies to cut down the cost or to give a better quality at a better price, so that we can stop depending upon the products coming from abroad. So coming to the steps in aligner fabrication. So this is the first step. We have to design and finalize the final teeth movement. If you see here, the gaps are closed. This comes under design and movement finalization. Once this is done, so if you see here, the whole treatment is planned in 20 steps. So here we have to keep 20 aligners to the patient. So how are we going to give these aligners to the patient? So we have to print 20 different models. These are the, using the aligner softwares, we can make the tooth movement into 20 different steps. And all these 20 different steps are printed using the 3D printer technology. These are the 3D models of different steps. And then this is how the tooth movement is supposed to happen in each and every aligner. And the final treatment outcome is going to be somewhere like this. Then a vacuum formed aligner is formed over this 3D printed models. So here we are using 3D printing technology for the models, and then the vacuum forming technology for the aligners fabrication. So that's how a 20 sets of aligners are being formed by using 20 different models of the patient at 20 different steps of treatment plan. So I hope you understood how a aligner is formed. Now we'll further discuss what we are going to do after that aligner is formed. So this is how the aligner will seat completely on the model. Then we, using the laser technology or laser marking or using the 4D milling machines, will be trimming this aligner from the model, separating it. So this is the model and this is the aligner formed over the model, and this kind of precise cutting is only possible with the machine cut. When we are doing it with the human interference, it will be very flat and it doesn't take the anatomy of the underlying model, and it is a cumbersome process and it takes a lot of time. When a machine works, it will be finished in 30 to 60 seconds. So the challenges what we are facing in aligner industry is, as we need to print multiple models, here we are not concerned about the accuracy or resolution of the printer. We are only concerned here for the bulk production or mass production of the models, because every patient requires 20 to 30 models to be printed. And we will be having, each clinic will be having somewhere around 4 to 5 cases in a week for aligners. And sorry, 4 to 5 cases in a month for aligners. So similarly, there are multiple clinics. So if a company want to start an aligner fabrication, it has to be at a level to produce around 3,000 to 4,000 models in a day. That is how the necessity or need for the fabrication of 3D printing of the models is needed. So the issues what they are facing here, because of the bulk production, what they will be doing is they will be using a low cost printers, which were somewhere around 20,000, 30,000 and 40,000, and they will be having multiple printers of that cost. But whereas in case of surgical guide resin, we need very precision, the guide has to be very precise and the resolution has to be very perfect. So in such cases, we mostly depend on SLA technology or DLP technology and high cost printers of Formlabs or Accurata, which will give resolutions up to 50 microns. And here people are using printers with of cost 30,000 to 50,000 to produce 8 to 10 models in each printer, and each fabrication is going to take around 1 to 2 hours. But the issues what they are facing with these 20 to 30,000 printers are, there is no auto calibration present in these printers. So every time they have to calibrate manually, and Z-axis calibration is going to be a big headache. So few times the models, they are perfectly printed, and sometimes because of the Z-axis issue, some of the models will not be printed properly. And frequent issues, and because of the multiple prints in a day, they will be having FEP sheet related issues. We have to find better FEP sheets which have got better strength and better longevity. And there should be a troubleshooting option with artificial intelligence. Just by sharing a picture of the failure, it has to identify what could be the reason for such failure. Is it the failure at the support level? Is it the failure of the FEP sheet? Is it the failure because of the resin? Or is it any issue with the resin tank? All these issues have to be sorted out by the artificial intelligence. So if such kind of troubleshooting options develop, it would be very easy even for the newbies to start 3D printing. Most of the people, they start with 3D printing, they end up without knowing what is causing the print failures. And coming to the resin related issues, here we will be using cost effective resins, which are around 2,000 to 3,000 rupees per liter. But these resins have got dimensional inaccuracies. So the aligner has to be formed immediately. If not, there is some amount of shrinkage happening within the model even after curing. And there is very high amount of resin wastage. If you see here, if we don't print complete model, there may be sometimes we may have to print entire model again. And if we try to be more precise and print a bigger model, there is more amount of resin wastage. So in this case, the people are coming with a new concept called 3D printed aligners, which avoids the printing of models. So a company already has started this 3D printed aligners. If this comes, resin wastage model printing is going to stop at one point, and we will be printing directly the aligners. And coming to the aligner trimming related issues, we need cost effective machines, which have to, if you see here, on a model, we'll be giving a marking, and the machine has to precisely drill and separate the aligner from the model. That is what the need of this particular machine. And these machines are costing somewhere around 10 to 12 lakhs. So there are some low cost machines also, but they are not as precise as the machines what I was talking in 10 to 12 lakhs. So we want some cost effective aligner trimming machines which can do the job very precisely. At the same time, they have to be cost effective. So these are the 3D printed aligners. Here there is no model. directly and these aligners are not vacuum formed. They are directly printed using a specific resin, and these resins are still under R&D, and they require a separate printer actually, but the resins have to be developed in such a way that even the regular printers can print these 3D printed aligners. And the only thing here, it is going to be the biocompatibility. This resin has to stay in patient's mouth for 22 hours per day, and patient is going to wear each aligner from 7 to 14 days. So the resin has to be very biocompatible, as it is going to be in patient's mouth for 7 to 14 days, complete 7 to 14 days. Now coming to the dental crowns. So earlier, as already discussed, we have cost-effective options where the casting was done and ceramic layering was done over it. And this is a complete manual work. And now we have come up with the DMLS technology where the metal is 3D printed using laser sintering, and it is layered manually with the ceramic. Here, the major work is based on the artificial intelligence, and there is very minimal human intervention. But a 3D milled monolithic zirconia is completely free of human intervention, and it has got very minimal errors. And here we will be using 3D milling technology. As you all know, 3D milling is always anyways better than the 3D printing technology. And 3D printing technology is far ahead of the casting technology. So we have also come up with few resins which are 3D printed crowns. These resins are ceramic infused resins, but here we need to develop a cost effective option. The resins are very costly. They are costing somewhere around 40 to 80,000 per liter, ceramic infused resins. So let us see how a single crown is fabricated. This crown is prepared actually. There was a cavity. So root canal treatment was done, then a post and core buildup was done. This is the margins, very well prepared. So we want a crown now over this prepared tooth. So this is the ExoCAD software which we are using. So the margin is already formed based upon a single click on the tooth. So this is the margin where the crown is going to sit. The AI has already generated a surface by adding a little more spacing for the cementation. And this is the path of insertion already designed by the artificial intelligence. How the crown is going to sit over that particular tooth. The AI has already identified the front tooth and back tooth and how the particular tooth is going to be, what is the buccal side, what is the lingual side, what is the dimensions of the tooth. Everything is designed by itself based upon the library which is already there in the system. So the crown is modified exact to the margins with very minimal human intervention, very few clicks required. And when such precise crown is formed, there is no issues with the high points. There is no issues with the fit of the crowns. There is no issues with the dislodgement of the crowns. This is the final crown or the STL data of the crown, which is designed using the ExoCAD software. So now this crown can be prepared either using 3D milling technology. If we use 3D milling technology, we'll be getting a zirconia crown. It can be made using the 3D printing technology, where we will be using a ceramic infused resin. And even 3D milling technology can be used metal using the laser metal sintering. So the thing is, here we need softwares which are very costly. We have to develop our own softwares which will supposed to be cost effective. Blue Sky Bio or the Real Guide softwares are the planning softwares, or the 3Shape Implant Studio is also a guide planning software. So a guide planning software is costing somewhere around 3 to 5 lakhs. Maestro 3D is a software which is used for aligner fabrication, which divides the total tooth movement into multiple steps. And ExoCAD is a software required for the crown fabrication. So every 3D technology is coming with very costly software. So we have to come up with our own softwares which can help to cut down the cost and also stop depending on the softwares coming from abroad. Now coming to the printing, STL files are being produced by using all these softwares, and we are printing them using the 3D printers. These 3D printers, they are ranging from 15,000 to 1.5 crore. 15,000 printer is any LCD printer available on Amazon, and the 1.5 crore printer is what I'm talking about, the laser sintered metal technology. So in our practice, we are using professional 3D printers in SLA and DLP technology. We have Accurata, and we also have Formlabs printer with us. But both the printers, they are costing in lakhs. And metal 3D printing needs DMLS machines, and they are even more costly, and they are costing somewhere around a crore, depending upon the number of lasers they are giving and the precision what they were able to make. And all these things matter, because in dental 3D printing, the precision is what matters. The crown has to fit at the level of microns. So you cannot have the precision at millimeters or centimeters. So when we are talking about precision, the cost is going at a higher rate. So we have to find a cost-effective option with smaller platforms for a regular clinical use. We don't need a bigger platform to make big crowns. So we have to come up with cost-effective options which can print a single crown, or at least 3 crown or 3 to 4 crowns on a single print. So such kind of cost-effective options will bring multiple dentists to buy them and keep them in their clinics and use them regularly for their patients. So before finalizing my presentation, I just want to show you how we work on Accurata printer. This is the Accurata printer. This is the platform, and this is the surgical guides placed over it. So these are the supports which we give. So if we see every step of the print, it is printed in 5-10 layers. There are multiple options of printing: fine, finest, standard, and fast. Fast is somewhere around 150 microns. Standard is coming at 100 microns. Fine is coming at 70 microns. For surgical guides, we will be using 70 microns. And when it comes to Curo crown, so that is the crown. Here we have the very fine option, 50 microns. So whereas the other software, what we will be using is the preform software. Here we are importing a maxillary model or a upper jaw model. it's very easy actually to work on freeform software. Because here most of the thing is automatically done. Even the support placements, even the orientation, everything is decided by the software. So if you see here, when I have imported a design, automatically the orientation and everything is designed by the. This is a skull model. We actually use this model for zygoma implants. So for mock surgeries, we'll be doing guide placement on this particular area and then drill through it and verify whether it is properly going into the bone or not. So this is when we click on auto orient, this is how it orients automatically. When we click on supports, based upon the angulation, it generates the support automatically. So this is how a 3D printed model is printed. And I also want to show you a case of a crown, which is. So this is a case which we completed just today at our clinic at evening at around 5 o'clock. So this is the bone of the patient, and we were able to precisely place the implant using the guided surgery. We have placed 3 implants in this particular patient, and after surgery, see the trauma is very minimal. So this is how the guide is, and this is how the implant is made through the bone guide with all PE. This is how the guide seats on the adjacent teeth. If you see here, it seats very precisely with no gaps between the teeth and the guide. Just give me a minute time. I will show you another case of crown. This is a 3D printed crown using previous permanent crown, which is ceramic infused. So earlier we used to have models, then the guides are supposed to be having this kind of gap between the guide and the teeth. And with the 3D scan, intraoral scan, the guides used to sit very precisely on the teeth. With the 3D printing technology, we were able to get better precision. So if we see how a guide is fabricated, here we first form an arch where exactly the guide is supposed to be placed. Then we will be doing a nerve formation to avoid any injuries to the nerves or vessels within the implant placement area to make the surgery as safe as possible. In the upper jaw, we'll be doing sinus marking. So this is how we have got a huge library of implants. We select the particular implant which we are going to place, and then we check the implant in all 360 degrees. So we'll be also cross-verifying it by placing a tooth there. So all the planning and of the implant and even the crown placement can happen within the system itself to avoid minimal surprises, to avoid surprises at the time of surgery. So when you come to the step-by-step protocol, we'll be doing a tissue punch, then we'll be drilling the bone, and then we'll be placing the implant. So all these happen through the hole which is present within the guide. And when we can precisely place the implant as planned, we can get crowns perfectly as executed. So even in guides, we have different types of guides. One is teeth supported guide, where the guide goes and sits on the adjacent teeth. In tissue supported guides, there will be no teeth. The guide will go and sit on the tissue. And the other one is a bone supported guide. Here the guide is fabricated to be seated on the bone. Here for this particular patient, all the teeth are mobile. We have to extract those teeth. So we cannot plan a tooth supported guide. So this is the 3D segmented data of the mandible. So the segmentation makes a key role in this kind of surgeries where the bone segmentation has to be very precisely done for a proper fit of the guide. So implants are planned parallelly. This is the guide which is going to sit on the bone. For this to happen, we have to expose the bone completely. So we'll be verifying all the measurements. So there is some 9 mm of offset, and for example, if there is 13 mm implant, we have to drill to a depth of 22 mm. So all such planning happens far ahead of surgery, making the surgery very simple and easy.
Get the budget. Excuse me. இப்படி இருக்குது
So I actually have a video which is not being played now. Okay. So that's all from my side. This is my phone number and this is my mail ID. Any kind of association or any kind of trials which we can work on, you can contact me on WhatsApp or you can mail me your ideas. So presently I am looking for resins which are biocompatible, which can have good strength. And similarly, ceramic infused resins, how to develop them, and all these things have to be done with some association with staff like you, with the help of your students. So I'm available for association. Uh, you can just contact me on WhatsApp or my mail. Thank you so much for this time. I hope I have not taken too long, and I hope my presentation was not so boring and too much into dental. I hope I have given some insights which can help you in fabricating some questions or in finding solutions for the problems what we are facing. Thank you.
Thank you very much for your wonderful presentation, sir. So I request all the participants, you can take the advantage of the chat box to raise your questions.
In the chat box, you can first type you if you find it useful.
Your session is very useful to the participants, even including me also, sir.
Okay, okay. I felt at some point I was too much into the dental part. I don't know whether it was whether it will be useful for you on your perspective. But my point is, you are into researches, you are into finding something new. I just want to tell you what exactly we are doing so that you can work on developing something which can be helpful for us and at the same time for also the fraternity who is working on it.
Thank you, sir.
Dear participants, you can click on the raise button so that we will unmute you so that you can speak directly to the speaker to get clarified.
Hi, sir.
Hi.
My name is Suchi. Uh, your presentation was really good. Actually, I was just curious to ask, have you like used any composites with hydroxyapatite or bioglass for like making the implants for dental applications? Because bioglass and hydroxyapatite, like I see it quite common. That's why.
Yes, actually, we have not tried printing them or we will be using them regularly in our day-to-day practice, which are available over the counter, hydroxyapatite and composites. But we never tried printing them because again, the when we are using something in the patient, we need some clearances, right? So that is where we are getting stuck. We need a product which has got cleared, FDA cleared, or has got minimum clearances from CDSCO. That is where we are being stopped from using most of the products which are already available. So we have, most of the time we'll be using hydroxyapatite. If someone can get a product which can print hydroxyapatite based upon the need, some of the cases will be having a bone defect, huge bone defect, which can be exactly filled with a 3D printed hydroxyapatite. But most of the times we compromise in such cases by doing a manual filling. So we are looking for such products actually. And even our implants, they are made up of titanium, and they are made up of the components, are some of the components are made up of stainless steel. So whenever we are working inside the patient's mouth, what actually happens is some of the components, they may slip and go into the patient's pharynx or esophagus. So in such cases, we are looking for some components which can be made, which can be magnetic, and will avoid such kind of happenings or mishaps within the clinic. So composites, we are keen to know how the materials are available, and we are even interested to work if anyone has got such material.
Okay. Thank you, sir.
And by the way, in composites, we have got resin, which we are already using it for 3D printing of crowns. And these crowns, they have got ceramic infused resin there. Initially, with the resin, we used to give only temporary crowns. And for now, with the composites which are coming with ceramic infused composition, we are even giving permanent crowns. But the resins are very costly, as I said. They are costing somewhere around 40 to 80,000 per liter. So if someone can come up with better ideas, better infusion, which can tolerate our occlusion loads or the forces within the oral cavity, that would be even more helpful. People are working on it, but getting approvals with us, as we have to place them in the patient's mouth.
Just one more doubt. So you said like it is a ceramic infused resin. What is
Yes.
the ceramic used?
Ceramic, actually, most of the dental work is based on the ceramic only. Most of the
Is it
ceramic,
zirconia or like there are multiple ceramics used in dental and bone implants. So which ceramic usually is used or like commonly used for the infused resin?
I I exactly don't know what ceramic they are using inside it, but we are using that ceramic infused resin, and I'm expecting it to be some glass or ceramic oxide, which even zirconia oxide is being used, which is in powder form, and they are infusing it with the resin to get better properties. It's still under many companies are still under study, and very few companies have got approvals. Revest is one such company, and Accurata has also got one resin with ceramic infused resin. So, and Detect, there is a company, and they have got that crown building option. And most of the companies, they don't disclose what exactly they are using because of the competitors in the market. Even we are using without knowing exact composition, what is there inside. They just say it is ceramic infused resin.
Okay.
Any more questions from the
With your
participants?
permission, sir, with your permission, I would like to uh, tell the facilities which are available in our institute, Ms. Suchi ma'am. Ma'am, we have a pneumatic extrusion based 3D printer in our institute. You can take the advantage of that instrument for printing medical grade materials. in addition to medical grade polymers, ma'am. Like if you'd like to print or if you'd like to develop any samples in the combination of polycaprolactone hydroxyapatite or polycaprolactone with any variety of calcium silicates or ceramics or glass particles, you can take the advantage of this instrument.
So, oh, thank you, sir. Is this a 3D bioprinting instrument or a 3D printing instrument?
It's a bioprinting, ma'am, but our system is not suitable for printing biogels like living. You can take the advantage of our instruments to print polymer composite samples for medical applications. Anyway, we can call it as a bioprinter, but it doesn't have a facility to print bioinks, ma'am.
Okay, okay, okay. Sure, sir. Thank you.
Hello, sir.
Yes.
Sir, is it audible, sir? Like, sir, if you have that pneumatic printer, so what kind of technology it will use, sir? Either powders or resins, like that. I don't know exactly pneumatic additive manufacturing. Is it like FDM technology?
No, sir, it is a pneumatic extrusion based setup, sir. Raghavendra, sir, there is a lot of disturbance from your side. If you don't
Sir,
mind, will
actually,
you
I'm
call me
traveling.
after this
Okay, sir,
meeting?
I'll call you later, sir. Then okay, sir. Thank you. Sir, you're Ajay only, sir?
No, Venkatesh.
Okay, okay, sir. I'll contact you, sir.
Sir. And dear participants, if you have any questions, you can unmute your mic and you can raise your question. Or if you have any clarifications, or if you have any doubts, if you need any clarifications to your doubts, you can unmute your mic and you can raise it. Revath sir, I have a few doubts.
Yes.
As per my knowledge, the chromes are there with the three different materials. One is zirconia, second one is DMLS based chrome, and third one is calcium based chrome. Which chrome is suitable for which teeth?
Okay. Uh, so generally, the 3D printing technology uh, for 3D milling, we will be using zirconia, which is available as circular blocks, and a 5-axis milling machine will mill the crown in 5 different directions and will get a crown out of it. They are very precise in terms of margins, but zirconia has not got enough strength to tolerate if it is in very minimum thickness. For example, if it is, for example, 1 mm thickness, there is a chance of breakage. So whenever there is a chance of more than 2 mm thickness, we suggest to go for zirconia crowns. And zirconia crowns, they are more aesthetic. They look so natural. So for the front teeth, generally we suggest zirconia crowns. And for the posterior teeth, where they need high forces and all, we'll be suggesting a metal crown or a DMLS crown, which has got a metal coping inside, and over it will be layering with ceramic. And whatever the other kinds of crowns, they will be only temporary crowns, which will not last for more than 2 to 3 months. So they will be generally given during the transition period until the patient gets the final crown. We'll be giving a temporary crown for a duration of 2 to 3 days, just to last. Most of them are made up of polymethyl methacrylate or acrylic kind of material. Even they are also manually made just by mixing the powders and liquids. So even now, such kind of crowns are being made using 3D printed technology. There is long way to go, and so many new inventions has to happen in this 3D printing technology, uh, where we can get crowns at an affordable price to the patients. That is what I was expecting from this 3D printing technology.
Okay, sir. Thank you. And the second doubt is, it's not doubt, it's a request. As a dentist, will you suggest us to will you suggest us to maintain few important points to make our teeth healthy?
So, uh, as usual, as many dentists suggest, we suggest you to visit a dentist once in 6 months, just because most of the areas can be missed by you when you are self-examining your teeth. A dentist can do a close examination and he can give a better diagnosis of what is happening inside your oral cavity. And at the same time, it's ideal to go once in 6 months for scaling, cleaning of your teeth, or at least plan it once in a year on your birthday to have a better healthy teeth. And while doing the cleaning, what actually happens is dentists will come across the areas of issues wherever there is an issue. If they are having a wisdom tooth problem, if they are having a areas where there is more amount of plaque accumulation or calculus accumulation, the dentist will guide you. Okay, and they will suggest you to go for what can be done in such areas. And if without going to dentist, what you can do is brush twice daily, do flossing. Okay, flossing is nothing but there is a thread which goes between the teeth to clean. And recently we have got something called oral irrigators or water flossers, which can be used with high pressure for cleaning between the teeth. So if you can and avoid multiple intakes of food, you have to avoid cavities. We just have to have minimal number of meals. So if they are having intermittent snacking or snacking in between, there is a chance of more amount of acid production in the oral cavity, and finally we will end up with having cavities in your teeth. So whenever there is a cavity, you are supposed to go to a dentist because tooth is the only part in the body which cannot heal by itself. If you have a backache, if you take rest, it is going to come down. But if your tooth has got a cavity, it needs a dentist intervention for sure. He needs to fill the tooth and get it treated properly so that the further complications can be avoided.
Okay, sir. Thank you very much. Can you list out a few symptoms to know about the teeth are going to, I mean, about to damage?
Yes. One important thing is bleeding gums. Many people they come with that sign. They say they eat something hard, or whenever they brush, they see their gums to be bleeding. In such cases, suggest is your gums are weak and you are supposed to have a better health of your gums. For that, along with the regular brushing, you are supposed to massage your gums towards the teeth, and you may need a professional cleaning or scaling. And that is one sign, bleeding gums. And the second sign is bad breath. So when someone is complaining of a bad breath from his mouth or a halitosis or smell coming out of his mouth, then it suggests that there may be a cavity or a tooth within the mouth which is causing food lodgement there, and it is fermenting over there and causing smell. And there may be several other reasons also. There may be plaque accumulation, calculus accumulation causing smell from the mouth, and those things needs physical examination and correction. And at the same time, there may be irregular teeth. So that irregular teeth may also cause calculus formation, and they may need to be corrected. And mobility of the teeth, when some teeth are mobile, either it may be because of heavy occlusal loads from the upper and lower teeth, or maybe because of aging process. So when such things are happening, you are supposed to take a professional consultation, which can help you to diagnose your problem. And also, and last and but not the least, most important thing is the pain. Never ignore a pain. Whenever your body says you are having a pain, it means something wrong or something bad is happening. When you have a tooth pain, just because dentists you consider they cause you pain, you avoid going there. But dentists are very friendly, they don't cause any pain. There are multiple options. We have needle free injections, and there are where we can reduce your pain levels and we can treat your pain effectively without much of the pain during the procedure under local anesthesia. So any bleeding, any signs of mobility, any signs of bad breath, any signs of all this pain, you are supposed to visit a dentist or take a consultation and get the problem sorted out.
Okay, sir. Thank you. And one last request, sir. In market, there are so many varieties of teeth brushes and toothpastes. Which one is good for adults?
Yes, I don't want to promote any particular brand, but I just want to say that whatever might be the brand you are using, the purpose of the brush and the purpose of the paste is nothing but to clean your teeth. Most of the people, they think that by brushing, their teeth are going to become white, or even they are expecting a whiter teeth. They are using a high forces on the teeth, and this is causing detrimental effects on the teeth. So I would suggest you to use an ultra soft brush. Brush has to be very soft. The bristles have to be very soft. Change the brush once in 3 months so that the bristles, when they flare up, they cause damage to the gums. So change your brush once in 3 months and use any kind of paste if there is no medical problem or a sensitivity kind of issues. When there is sensitivity, you are supposed to use a medicated toothpaste. But when there is no sensitivity, you can use any toothpaste what you're using, close-up, Colgate, or anything will work. But the purpose of brush and paste is just to clean, not to make your teeth whiter. So you are supposed to brush your teeth, upper teeth from top to bottom and lower teeth from bottom to top. There is a specific way how you are supposed to brush your teeth. Never do a brushing like this. This will cause damage to the enamel and it will cause abrasions on your teeth and you will develop sensitivity over time. Just brush 2 minutes, and that 2 minutes are supposed to be only for brushing. Don't mix and match your brushing with several other tasks. People generally they do. They while brushing they want to read the newspaper. While brushing they want to use the washroom. While brushing they want to do hell lot of work, but they don't concentrate on brushing. 2 minutes is enough. That 2 minutes is only for brushing. That is what I can suggest.
Coming to the paste, sir.
If you want me to tell some brand, what TVs are saying, Sensodyne is good enough for sensitive teeth, and Colgate is good enough for all your regular teeth. And for kids, I would suggest some toothpaste like Ketodent and Cheerio by Reddy's and some other good brands. Uh, they have got some good flavors and they also have got fluoride inside them. So this will avoid cavities in the children. So Cheerio Plus and Ketodent for kids. For adults, Sensodyne or Colgate.
Okay, thank you, sir.
Revath sir, thank you very much for enlightening about the dental implants and even oral cavity point of view. Also, I would like to express my sincere thanks to you for the wonderful session. Thank you very much, sir. Revath sir.
Sir,
One participant made a call because he is unable to raise a question.
okay.
What is the problem for teeth broken, sir?
Okay. Uh, If if the teeth are broken, there are multiple reasons. One could be uh, a cavity in the tooth. If there is a cavity in the tooth, over time, what happens is the tooth becomes brittle, tooth becomes weak, and when you eat something hard on it, it will break. So before coming to the level of breaking, it will give you multiple signs and symptoms to let you know you are supposed to go for treatment. So when you ignore multiple times, that is when the tooth is getting to fractured. Tooth has got the strongest part in our body, the enamel, which is so strong, but the soft drinks, what you drink, the carbohydrate rich diet, what you are having, is causing detrimental effect over it over years. When you are having the cool drinks, when you are having the uh, sugar content diet, it is causing cavities even in the enamel. So uh, one such reason is cavities. Second reason could be high occlusion forces. Maybe you are clenching your teeth so hard like this at night time without knowing, or with maybe you are knowing about it or may not be knowing. But the thing is, your high forces on your teeth is causing attrition or the wearing off of the teeth. And at one point, the teeth becomes very weak and it becomes fractured. And there is another habit called as bruxism. They are called as night grinders. They grind their teeth in sleep. They do grinding at sleep, which will be very audible at night. You can hear them when you sleep beside them. Their clenching or their grinding can be heard. So in such cases, because of that continuous night grinding every night, there will be a chance of fracture of the teeth, and sometimes trauma. When you go out, when you get hit with something, then the tooth may get fractured. And all these cases, if it is an initial stage of fracture, it can be restored with a small filling material. And if the filling is extending, if the fracture is extending deep into the pulp, then you may need to go for root canal and crown over that particular teeth. And if it is even extending up to the roots, then you may have to go for extraction of the tooth and place implant over there.
Thank you, sir. Thank you
Okay.
so much for the dear participants. 10 minutes break. Again, we will continue with the second session of the today's with don't go anywhere. Please stay back, stay connected. In 10 minutes, we'll have the second session. Thank you. Dear participants, welcome back to the second session of the ATAL FDP titled Advanced Biomaterials for Orthopedic and Tissue Engineering Applications. Before proceeding to the next session, I would like to introduce the today's speaker for the second session. Dr. Chaithanya Vinay Valivarthy is an accomplished research engineer and postdoctoral researcher currently working at University D'Orleans in Bourges, France, with a PhD in mechanical engineering from Vellore Institute of Technology. His research focuses on the fabrication, characterization, and modeling of exotic forms for medical cushioning applications. Dr. Chaitanya has extensive experience in material testing, fabrication, and utilizing finite element analysis and artificial neural networks to assess the piezoresistivity in polymers. He has a strong background in materials engineering, specifically with carbon nanotubes and auxetic materials and structures. He also served as a senior research fellow at the Council for Scientific and Industrial Research in India, where he specialized in the optimization of processing parameters and material modeling of auxetic foams. Chaitanya conducted significant research at Purdue University, USA, as part of overseas visiting doctoral fellowship program, where he developed advanced computational models and image processing software using Python and convolutional neural networks. His academic journey includes a master's in computer aided design from SRM University and a bachelor's in mechanical engineering from Jawaharlal Nehru Technological University. Chaitanya is fluent in multiple languages and skilled in various software tools, including MATLAB, Abacus, ANSYS, and Fortran, making him a valuable asset in both academic and industrial research environments. His contributions to the field are well documented through numerous publications and patents, and he has been recognized for his outstanding performance and innovative project ideas. With this brief introduction about Dr. Chaitanya Vinay, I would like to hand over the platform to Dr. Chaitanya. Thank you.
Thank you so much for your kind introduction. Uh, it's like I'm very warm. Like I felt very good that you have been like introduced and you have been invited me to talk about my work here on faculty development program on advanced biomaterials for orthopedic and tissue engineering applications. So myself, as he already introduced, so myself is Dr. Chaitanya Vinay Valivarthy. Currently, I'm working at uh, it's a LAMI laboratory. There are two universities, and also there is one institute which is funded by government in France. And we found recently one laboratory called LAMI laboratory, which is completely working on piezoresistive uh, uh, sensors for food processing applications. So previously I worked on bioengineering. So in this today's presentation, I'm going to talk about research opportunities. So I think there are few PhD students along with faculty. So just want to let them know what are all the current research opportunities around the world. And I'm going to talk about my experience. And next is I'm going to talk about the design and development of auxetic materials for rehabilitation applications. And also going to talk about my current work, which is a study of piezoresistive elastomers for food processing applications, and few startup funding opportunities, because there are many opportunities nowadays to start like to convert the technology into the uh, like uh, startup. So it's a very easy compared to the previous years. So I just want to give a brief startup funding opportunities at the end of this talk. And initially, if we come talk about some opportunities for PhD scholars and PhD holders, so one of the major opportunities are from CSIR and SCRB. If somebody are currently doing PhD in their area, so you can write a proposal as a principal investigator and seek these fellowships. So one good funding you can get from CSIR in terms of senior research fellow, and the second is through SCRB you can get funding from OVDF board, which is Overseas Visiting Doctoral Fellowship Program. So from this program, students can go to Purdue University. So from the government of India have an MOU with Purdue and also University of Alberta in Canada. So students who are interested, they can go to these two universities. Initially, you can contact the professor and then write a fellowship and write a proposal like for a fellowship. And based on there is a committee. So generally, what they have selected is there are more opportunities for bio applications and also the current like current hot areas like sensors field, and India is going to manufacture chips, which is semiconductors. They are looking to manufacture a semiconductor. So these areas have a good opportunity to go and work there. And the third is the France, which is EFIL fellowships. If you are in PhD, you can go with EFIL fellowship program. So you can select one university and contact the professor, and you can approach them. And second is Banting postdoctoral fellowships from Canada, so which is a very good fellowship program to go to Canada. And next is Fulbright to USA, and then Marie Curie Actions. So this is a good fellowship program to explore the Europe. So these are the few fellowships programs to go abroad and work with, like to get an international exposure. And when it comes to my experience here, so I started my PhD on 2017. Right, like before that, I worked in on college as an assistant professor. So after that, I started worked on research, completely into research from 2017. So initially, I started with simulation on auxetic forms using Abacus. So in this, I have written some Fortran code to simulate the behavior of like auxetic forms using Abacus. And then after later I realized like, okay, we need a auxetic forms are not have fully explored. So initially we want to explore experimentally, and we started fabricating the auxetic forms and get the data and using the data to model the forms using simulations. So next we have started with material modeling of auxetic forms using MATLAB. uh, so here we have come up with a new material model, which is nothing but an equation which just represents the mechanical behavior of the foam. So using that equation, we can use that equation to take that equation and fit into the current experiments and using optimization technique and use those parameters into the simulation. So next is I have started working with the structures, which is a very interesting for me. Like I was very fascinating to work on these structures, and then initially I started with auxetic structures with the reentrant patterns, and then uh, I've designed and 3D printed using a Formlabs 3D printer. And next, we have used convolutional neural networks to create a to just identify the like deformation patterns in auxetic structures. And then currently, like from 2024 January onwards, I started working with the design and development of piezoresistive elastomers, so which is for food processing applications. So generally these piezoresistive elastomers are used to they are using as a piston rings inside the
Excuse me,
engine.
sir.
It's not a complete engine. Can you
Excuse
hear
me,
me?
sir.
Yeah,
Sir,
yeah.
actually the slide is not moving, and that slide is also it is not in presentation mode, PPT presentation mode. So can I? Yeah, sir. Now it's in fourth slide, sir.
And Vinay
Initially it
sir,
was.
you please select slide share mode and keep on changing your slides.
Okay, this is my current slide. So can you able to see this one, or you
Yes.
are you seeing another one?
No, third slide. I think I'm seeing, sir.
Now?
Now in third slide, sir.
No, still in third slide. Okay, I think there is an issue. Let me change this slide. Okay. Now, can you see the current slide, which is my experience about my experience, or are you seeing the third slide?
Fourth slide,
Fourth one,
sir.
sir.
Yeah, now you're seeing fourth slide. Okay. Previously also I'm in fourth slide, but I think for you the third slide is
No, sir,
displaying
for
it.
first slide. Previously, I was saying for first slide.
Okay.
You
Okay.
are on.
Yeah.
You are in the fourth slide. Okay, sir.
Yeah,
Okay,
I'm in
now
fourth
continue,
slide.
sir.
Okay. Yeah. Okay. Sorry. I think there is a glitch here. So, okay. Can I continue now?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yeah, okay. So here about my experience, like one is design and development of piezoresistive sensors. So these sensors we are currently using on piston rings. So this is not an engine. Generally, they in food processing applications they are using in France. They are using some specific kind of an engine kind of one. So it consists of piston and also a ring. That ring is having friction with the cylinder wall, but there is a problem like if they don't know that that complete ring is made with an elastomer is nothing but a rubber kind of material. So when this friction is happening, so because of the deterioration, people couldn't they don't know like when this ring is going to fail. So instead of that, so they are come up with a new project which is a government project. So they formed a uh, one uh, one committee called Clubber. So they are trying to design a piezoresistive elastomer, which is the piston ring itself act as a sensor. So in this project, so I'm going to work on designing a sensor. So we are using some nanoparticles which can act as a sensor. Like I mean, inside nanoparticles there are carbon nanotubes, carbon black particles. So these particles can use it to transmit the electrical conductivity. So based on that, when mechanical strain is applied on the ring, so there is a formation of conducting parts. So based on that, the electrical conductivity change. So based on that change, the signals can be transmitted to the receiver. So based on that, we are currently working on that to design a piezoresistive sensor, particularly for that food processing applications. So now let's dive into this more uh, research, like more deep research inside oxytic materials for rehabilitation. So initially, this is like in this first, there are two parts in the whole session. One is about design and development of oxytic materials for rehabilitation. Second one is on sensors. So initially, I'm going to talk about what is oxytic material. I'm saying oxytic, but let's talk about like what is it and how we can design and what areas we are applying these materials. So initially, if we come about what I am working on, it's completely on rehabilitation applications. So there are many kinds of rehabilitation applications, but currently we are working on wheelchair seat cushions and stump socket interface, which is called prosthetic liners. Suppose there is an amputation, and if somebody are using the socket, this is called socket. So this is called liner. So first they wear the liner, and then after wearing the liner, they just wear the socket. So this is called stump socket interface. This liner, we can call it as a stump socket interface. And the third one is hospital mattresses. So currently, like previously during my thesis, like we come up with developing a new foam material which can reduce the problems for these who are using these cushions as a wheelchair, and also the stump socket and also the hospital mattresses. So now cushion is like it could be polyurethane foam, it could be like silicone foams. So generally for these hospital mattresses, they are using a polyurethane foam. So any cushion, it should not be too soft. If it is too soft, there is a problem of sagging, and there is no proper back support, and it causes back pain to the user who are using, like who in the patients who are on the hospital beds. If the cushion is too hard, it distorts the back and also the pressure concentrating on these specific areas, which is shoulders and pelvic area. So it is an unnatural. So any ideal cushion, it should not be too soft and it should not be too hard. Like, I mean, it should not be too soft and it should not be too far. It should be lies in between. So in order to avoid these problems, and there are many like then ideal cushion is needed. So along with this, there are many other applications. Like suppose, for example, if it comes to wheelchair seat cushions, it causes pressure ulcers. Pressure ulcers, it damages the skin tissues. So here the seating position also matters a lot. So along with sitting position, the cushion is also plays an important role to avoid these issues. So generally, if it comes to some socket interface, the same kind of problems. So we have seen the same kind of problems are there with these three applications. So we wanted to develop a cushion which can ideally solve the problems in these three particular applications. So generally, these three applications, like these three in applications, the all problems are caused due to uneven compression, due to mechanical breakdown, like mechanical parameter breakdown, which are compression, like uneven compression and shear acting on a specific areas, and also indentation, and also the high temperatures, because the temperature, it should give more comfort to the user, and if temperatures are generating inside the material, it causes the breakdown of a screen breakdown. And next is fatigue. So when there is a walking, and when the user is doing some activities like walking, and if he is just moving his leg with amputation, so it causes fatigue. So this is also one of the important mechanical factor which causes the skin breakdown. And second is bacterial and fungi growth due to sweating. So the cushion should be antibacterial as well, because to stop the bacteria when they are using for a as a liner material. So in order to avoid these all problems, we need to develop a ideal cushion which can reduce all these problems for the user. And these are the factors affecting wheelchair cushion performance. One is interfacial pressure, interfacial distribution at the body and cushion, and the second is shear and friction stresses, as we already discussed before. And third is seating angles and temperature and relative humidity at the body cushion interface, and transmissibility, vibrational transmissibility, because when the wheelchair is moving towards, there is a vibrations. So due to that, also the cushion performance influence, like it can influence the cushion performance. And second is major problems associated with wheelchair cushion users: pressure ulcers, tissue damage, blood flow, blisters, and other chronic problems. These are the problems generally, these are the major problems for all these users. And next is factors affecting prosthetic liner performance, the same kind of properties which are same for these three applications. Next, we need a smart material. Generally, what is the difference between a normal material or smart material? So like, if we change one or more properties, that can be significantly changed into controlled fashion by external stimuli, like uh, stress, moisture, electric, magnetic fields, light, temperature, chemical compounds. So any material, we can induce any property, we can enhance any the property of a material, we can call it as a smart material. Can we use oxytic foams for these to avoid, like in particularly in these applications? It's a hypothesis, because previously nobody have used this. So we see what is oxytic material. Oxytic materials is generally negative Poisson's ratio material. We'll see the definition for the slides. But is there any, like previously anybody have used, if we think about anybody used before, Zeng, like from University of Florida, he invented an oxytic foam for prosthetic apparatus, but he have a patent on this, but he never used in a current market. But let's see we can use it or not. So generally, what is oxatic material? So as I told you about negative Poisson's ratio material. So the difference between normal material and oxatic material is when we stretch in one direction. So normal engineering material, it reduces in other direction. But oxatic material, when we stretch in one direction, it increases in other direction, which is very strange. Like we can't see in any engineering material, but we will see how we can achieve this deformation behavior for oxatic forms. So why I'm saying like, okay, we can use oxatic material. So there should be one reason like why I'm saying like we can use this material. One of the reasons are indentation behavior. It has good indentation behavior and good bending behavior, which is called synclastic and anti-clastic bending behavior, which can adapt the uh, the surface of if it is stick to other material, it can adapt the surface of the other material very easily. And it has good fracture toughness compared to the normal material, and also it has good stiffness and good stress distribution, which is important factor in rehabilitation application. And also it has very good acoustic damping. So these are the major reasons we have selected to use this oxatic material for rehabilitation applications. So next is, these are the properties influencing cushion performance in rehabilitation: pressure distribution, indentation, shear, compression, impact, and transmissibility. The same properties in oxatic forms, it was enhanced. One is high pressure distribution, indentation, and high shear stiffness, good compression, impact, and also good acoustic damping. So these properties are matching like what we need exactly to which are influencing in cushion performance in rehabilitation. So this is the like major reason we have selected the oxatic forms for rehabilitation applications. So we have made one framework to any smart material before using as a in rehabilitation applications. So we need to do a like a method. We need to adopt a method because before going to clinical trials, so it is very important to test the material, which is not we are not using generally, like we are not using in vivo and in vitro, but it is important to uh, test the material in various ways uh, before going to the clinical trials. So initially, we need to we need to start with the PO forms and then convert that into oxatic forms and then optimize the parameters for fabrication of oxatic forms. And we are synthesizing the PU and cast oil based and silver nanoparticle based PU forms. And then we are converting that PU forms into oxatic forms. And then we are characterizing we are doing characterization like scanning electron microscopy and all those stuff. And after that, we have mechanically tested the forms and then we perform the antibacterial studies. Now this part is completely on developing a smart material. So after developing a smart material, we need to test like in many ways, like through mechanically and also like in using the finite element analysis, like you're using simulations. So first thing is like we have a material models, and then we have two material models. One is hyperelastic and visco hyperelastic material models, and we use that material models to uh, so before going to FEA, we are like come up with a new material models, and then we are performing the finite element analysis, and we check like what are the stresses and what are the strains. So before directly sending to the user, we can test before like yeah, it's a cushion material. We are not using inside body, but still we need to test in many ways to avoid the problems to the user. So when it comes to foam fabrication process, they like generally the major components we are using to make a PU foam. Why? Because we have selected a PU foam, polyurethane foams, because these foams are completely non-linear and based on the it will change the properties of these PU foams can change based on addition of particles. If we add some sand particles, styrene acrylonitrile particles, the PU foam, the polyurethane foams like load bearing capacity will change. So these forms, the two major components are there. One is polyol and diisocyanate. So here the polyol and isocyanate plays an important role to form a PU foam, and also we are having the water and catalyst. And if I want to make any PU foam with castor oil, so we can reduce the polyol content and increase the castor oil content. So by using the synthesis mechanism, so we are preparing these PU forms, and also with PU SNP, and also we combined, for the first time we have combined castor oil based and SNP together and make a PU form, and use this PU form to convert these PU forms into the oxatic forms. In further, we can discuss like how we can convert it. So this is a foam synthesis process. Initially, I've added polyol and SNP plus CO, and then sonication for 5 minutes, and then we have added water and then catalyst blend, and we stirred up to 3000 RPM for 30 seconds, and then we add the isocyanate, and then we stir at 3000 RPM for 15 seconds, and then we PU foam formed, like if we like the shape of the PU foam is completely based on the shape of the container. So these are the foams. We have this layer. We are just taking the middle part of the foam. We are not taking the surface part of the foam. So now we have made this PU forms. We want to convert this PU forms into oxidative forms. So we need to convert these forms into oxidative forms. So initially we are using the methodology called triaxial compression and heating method. So here any foam, like we are taking a container, aluminum sheet based container. The size of the aluminum sheet is 1 mm. So we have taken a container. So the container size, the volume of the container should be less than the volume of the foam, conventional foam, which we already prepared before. So we insert this conventional foam inside the container, and we closed with a lid. That means this, like we are maintaining one compression factor. Compression factor is nothing but size of the foam divided by, volume of the foam divided by volume of the container is nothing but compression factors. So there is no standardization of these foams, but we have used the trial and error method to conduct various compression factors. So we have achieved an oxidicity with 2.07 and 2.96 compression factor. And after taking this aluminum like box inside consists of foam, we can put it in a heater, and we can heat up to 200 to 250 degrees Celsius, which is also not standardized, because as I already mentioned, PU foams are not, there is no standardization of making an oxidative foam, because PU foams, if we change one compound to make a PU foam, the properties will change. It won't change drastically, but there is a slight change in properties. So based on the compounds we are using, that's why we make our own foams instead of buying the PU foams from outside and make these oxidative foams. So the three factors which are influencing the foam fabrication, oxidative foam fabrication process, which are these are compression ratio, heating temperature, and heating time. These are the three major factors which are influencing the factors of making an oxidative foams. So we can see this is a 2.06. So you can see oxidicity, which is very less. So as I already mentioned, like for normal foams, you are stretching a material and it is reducing this side. So you're stretching in longitudinal side, in lateral side it is reducing, the size of foam is reducing. But when it comes to oxidative foam, when you stretch, it is increasing here. If you deeply observe here, it is increasing. If I increase compression factor, this like this size increase will go like it will further increase more. So if I increase this compression factor, as you can see here, the difference between normal and PU foams, if you see very deeply, like you can understand the difference. Next. Now determination of Poisson's ratio values. So initially we are capturing this video and then converting that video into 100 images, and based on the digital image processing using MATLAB. So we are converting the normal images into boundary images, and then we are calculating the lateral strains and longitudinal strains for the auxetic forms, and we calculate the values of auxetic forms. So these are the Poisson's ratio determination. So if you see here, the auxeticity, like if you see here, some forms are having negative Poisson's ratio. This is a normal form, these are auxetic forms. So it consists of negative Poisson's ratio values. So for certain extent only this auxeticity will lie inside the form. So if you further stretch this form, if you stretch this form for certain displacement, it works like it behaves as an auxetic material. But after, if you further stretch more than that, like 20 mm, 30 mm, more than 30 mm, it behaves like a normal material. So this auxeticity lies inside the material only for certain time. So that shows here in this graph. So if you displace, if you stretch the foam for 5 mm displacement, 10 mm displacement, 15 mm, so initially it behaves like an auxetic, and then going to the normal material, like behaving like a normal material. So auxeticity is completely non-linear. So this behavior is completely non-linear inside forms. So these are the PU forms with castor oil, and these are the PU forms with the silver nanoparticle, and these are the PU forms with CO and SNP. So these are the scaling electron microscopy. Here we can see the buckling phenomenon. So these three A, D, G are normal forms. So A is a normal PU form. This is PU form with castor oil. This is PU form with silver nanoparticles. So like these are the auxetic form with compression factor 2.06, 2.96. So this is for castor oil based PU form, auxetic form with 2.0696. So when these are the normal forms, we have seen that when we stretch that foam, like because we are keeping the foam inside the container. So when we do that, so these pores are completely accumulated with the ribs. So we call this as a ribs in the cells. So these ribs are completely go inside the pores, so which undergoes a buckling. So when we take out the foam and when we stretch externally, hello, yeah. So when we stretch externally, so these completely voids are filled with the ribs. So this phenomenon is called buckling phenomenon. So this phenomenon is common in terms of all forms like CO and SNP forms. Now, then these forms, we have conducted the uh, cyclic compression tests, and also stress relaxation tests, which are creep. Also we also conduct the creep, and then we have used the MTS machine here, and then we calculated the energy dissipation values from these studies. So the standard for this is ASTM D3574, which is a standard for normal forms. Now these are the results for compression results for the foams. Compression results for the foams. So here we have for normal foam, we have linear elastic region, and this is a nearly point, and then it goes to plateau, which is called elastic collapse. In this region, there is a collapse of elasticity, and then densification for normal foam. But whereas for auxetic foam, initially there is no linear elastic region. It completely like behaving like a hyperelastic, and densification. So there is no elastic collapse also. There is no plastic deformation in auxetic forms, so it's completely elastic. So that's why we are calling it as an hyperelastic behavior, and the models for these also hyperelastic models we are using. Next, so these are the CO based and SNP based PU forms. The same trend is like going on in these compression test results. There is no linear elastic region, there is no yield point, and there is no, we can't know, like we cannot know exactly where the yield point, but from the previous studies they have mentioned like when the curve is turning towards the densification, they are considering that point as a yield point, which is not clear till now, because hyperelasticity is completely not non-linear effect, like non-linearity. So we can't say exactly like where the yield point, we can map the yield point exactly for the forms. But whereas for normal form, we can know the yield point for certain level, which is the end of the linear elastic region. We can say that it's an yield point. This is also same trend is happening for CO, SNP based PU forms and APU forms. Now, when it comes to the cyclic tests, so we are running the cycles, 10 cycles to avoid the Mullian effect. So Mullian effect is that like when you do the complete cyclic test, so there is a difference in change of cycles. So in order to maintain the cycles constant, in order to remove the effect like strain, we can call it as a strain hardening effect, Mulline's effect. So in order to avoid that effect, we are conducting 10 cycles and we are taking the 10 cycle, we capture the 10 cycle. So after 10 cycles, the foam becoming constant, the cycles are becoming constant. So we are taking the constant cycle, which is like which can remove the stress hardening effect after 10, like after certain cycles by running the cyclic tests. So here we have two behaviors in the cyclic test. One is hyperelastic and also viscoelastic. Viscoelastic is means so there is a loading and unloading curve. If the loading and unloading curve are in the same path, there is no viscoelastic component. But the loading curve and unloading curve, there is gap here. So which consists of we can say there is a viscoelastic component. Here energy dissipation. So we possess when we increase the nano materials like SNPs and CO, when we add some additives inside the PU form fabrication and we convert that forms into oxidative forms, we got very high energy dissipation for CO and SNP and APU forms. Like when it comes to antibacterial tests, the antibacterial activity of all forms against both gram positive and gram negative, which is SRAs and SAP epidermitis, and gram negative P. aeruginosa and E. coli bacterial stains were studied compared in vitro using microbroth and dilution method. The bacterial stains were inoculated into 10 ml of nutrient broth, which is high media, and incubated in orbital shaking incubator for 24 hours at 37 degrees Celsius. And after incubation, we have removed the wells and used the 20 microliters of each bacterial suspension were inoculated on nutrient agar plate and incubated again. So using these two bacteria, two positive bacteria, two negative bacteria, we are trying to like get the antibacterial activity out of nutrient agar plates. So these are the results. So these are the results for antibacterial studies on CO based forms. So when there is a like addition of CO, there is an antibacterial activity, but which is very less. But when it comes to the silver nanoparticles, we got the very good behavior because silver nanoparticles are highly antibacterial properties. We can look into the other nanoparticles also, which are very low cost because silver nanoparticles are a little bit expensive compared to other nanoparticles. So which possess an antibacterial property. Now, when it comes to the modeling, so we have come up with a new metal model, which is hyperelastic model, Ogden model. So model is nothing but which is a representation of the behavior, mechanical behavior, because it's a non-linear material. So these models are also non-linear models. So Ogden model, metal model was introduced by R.W. Ogden. So lambda 1, lambda 2, lambda 3 are stretches. So these are stretches. And then nu is Poisson's ratio. So for the first time, we have incorporated this Poisson's ratio into Ogden model along with viscoelastic component. So this is the first time we have done this. So here we have lambda 2, which is a stretch in second direction. We incorporated this Poisson's function inside the Ogden model. Next is, this is a first order Ogden model. So if we increase the parameters, we have second order, third order, fourth order also. But it is suggested that first and third order gives a good result, good match of results. So these are the results for fitting. So this is an Ogden model, which is not suitable for normal forms, but it is suitable for oxatic forms. When we increase AP1 and APU2, like increase the compression factors. These are the abacus results. Like inside abacus, there is a problem. Like there is no. Hello. Hello. Yeah. Can I continue, sir?
Yes, sir.
Yeah. Okay. Okay. So we have this abacus. Like there is a problem with abacus software. Like there are any FEI software. If you see like ANSYS, abacus, they have only existing models like linear, non-linear. They have Octane. But if we come up with a new material model, we wanted to incorporate that material model inside abacus. But we need to code it like using Fortran. If you have a new material model, there is a provision in abacus, you can make a Fortran code and link that material into the abacus. So for that you can link the Fortran compiler with abacus, and then you can write your own code. You can write a coding, you can make a coding in abacus, because this particular material model is not available in abacus. But still we are trying to code this both behaviors in abacus. Mostly we are going to achieve it in soon. Next is 3D printing. When it comes to the oxatic structures, so oxatic structures also have a very good behavior, and currently a lot of researchers, like recently, they have started working on oxatic structures to use as a bone scaffolds, scaffolds, like especially trabecular bone structure. So trabecular means inside the bone, like femoral bone is like there is a bone inside the human human femur. So outside bone is called cortical structure, and inside bone is called a trabecular structure. The porosity are also very high in trabecular structure. So researchers are coming up with the new ideas. Like if they have any, like can we able to use this particular structures inside the trabecular bone. So they are matching the modulus. We need to match so many parameters. So before that, this is a good area to explore these materials for bone implant applications. Next is I'm going to talk about, after this one, I'm going to talk about piezoresistive composites. And there are other works I have performed. One is on design and simulation of stent materials, cardiovascular stents, and also design and simulation of stump socket interface and amputation. So I just wanted to know, like from the audience, like if you have any doubts on this topic, you can ask me, because still there is a part two for piezoresistive elastomers, which is a different topic. So if you have any doubts, you can ask me. Maybe I can give you 2 minutes to ask any doubts. I'm happy to answer you. Hello.
Dear
Yeah, yes,
participants,
sir.
so please unmute yourself and ask the doubts that you have.
We are all fatigue. We are like that because
Yeah, I've shown
yeah,
wear and fatigue.
yeah, sir. One thing that fatigue we are, because that too, uh, after implantation some wear is happening with that bones. So I want to know that what is that fatigue wear?
On
particularly
this, like, I mean, you mean like for structures or for foams? Like you need for
for a
structure.
structure, sir. For a structure. Now I'm not talking about the foam, sir.
Okay, okay, structure. Okay, so in here, like, because what I have done is like, yeah, if we are in fatigue also we can study. We are in fatigue also we can study. If we make titanium, like if we made this material with titanium, like if we want to make some titanium based
Yes, sir. Titanium, sir. Yes.
yeah, so for the to print this structure in titanium, it is very difficult because we have tried with SLM also, selective laser melting, and also metallic 3D printer, which is very difficult to make. Maybe with SLM, it is possible if you have a good mission like SLM mission, it is possible, but it is little bit difficult to attain this structure because the structure has many problems. When it comes to VR, yes, VR also is there. You can test the VR, which is a good it is a good area which I haven't explored because still research is going on. Maybe it's a good your question is a good one. If you want to work on that, it's a very good idea to work on this because nobody have explored the VR and fatigue for these structures.
Okay, thank you, sir. Sir, I want to also know that one question, sir. That
Okay.
antibacterial test, sir, you have done also. So, I want to know that how to improve that antibacterial of the existing material. So that suppose that I am working on the titanium alloy of grade 5 or titanium ELI. So I know that how to that change after the surface after the changing the surface energy it improve. But after that we can also have a something coating material is there so that I can improve that antibacterial surface
Yes, yes,
like
yes,
that, sir.
exactly. So you can do surface modification process to improve the antibacterial effect, and you can make the titanium alloys into biocompatible materials using surface modification. Some people do like they change the properties also. You along with surface modification, they do laser shock peening to change the material properties, and you can do, yeah. But mostly, if you want to make the antibacterial, so you must do the surface modification process, like coating. You can coat with various chemicals, like based on that you can make the model into antibacterial. Yes, you can do it.
Yes, sir. But my concern is that, sir, after coating, that strength will of surface strength will be maybe not have a existing material. So maybe after the implantation, will start rubbing with each other because after implantation, anyhow that rubbing action will take place. So the thing is that, sir, what is that after the coating it may be started more erosion over that over period of time, sir. So which material is better for that coating, sir? And that will also in parallel that will also show good antibacterial properties. So do you have any sir idea any material have like that?
Currently currently titanium alloys are the top, I can say, because I am not more in expertise into that, but still I can say titanium alloys are the top. Why? Because titanium has more strength, but less weight, more strength, and also as far as I know, like most of them are using titanium, cobalt, chromium, but cobalt chromium has some toxic properties, I guess. But zirconium alloys also you can try to make this one, and also you can think about the aluminum alloys. But aluminum alloys is based on the strength also, because uh, it depends on the where you are using the implants. You have femoral implants, you have tibial implants, you have the hip implants, and some people are using maxillocranial implants. So based on where you are using, the material also will change. So it's
Okay,
our choice. Like it's a based on the choice of material is based on where the application, like in which implants you are using. So I can't say um, it is subjective, I can't say
yes, sir. Yes, sir.
generally,
Yes, sir. Yes,
but
sir.
it is subjective, like it based on like which application you wanted to use.
Yes,
Suppose
sir.
if I wanted to use femoral implants, it's different, like the wear is different and the fatigue is different. So all the mechanical properties are different. So my suggestion is like maybe you have to choose like which area you wanted to work. So based on that, the material preference should be there.
Sir,
So
yeah,
initially,
actually, sir,
yeah.
in hip plant or in dental implants, it is necessary to do that antibacterial property, sir.
Yes, in hip implants, we need to select the material. Like I can say the material nowadays, material itself, without when they do surface modification, they want improving strength. At the same time, they want to make it anti corrosive property, right?
Yes, sir. Yes.
So it's all things they are considering into the mind, and they are doing surface modifications nowadays. So surface modification itself is a big area to explore. You have wear properties, like if you want to come up with the
Yeah,
properties, you need
tribocorogen,
to,
all these things will
yeah,
consult with
tribocorrosion, all
the.
this. So based on that, which property you are selecting, there are many properties, but which
Yes, sir.
property you are selecting, so based on that you have to do the modification. But at
Sir,
the same time, you should not
okay, sir.
compromise with strength. Yeah, you should not compromise with strength and all. Yeah.
Sir, can you explain one more time, sir, that antibacterial property you have to the procedure you already explained, sir?
Yeah, this procedure is for cushions.
Uh,
um,
One slide is there, sir.
this pro- yeah,
Yes, sir.
this
Yes, sir.
procedure is for cushions. This is not for metals. So
Okay, sir.
metals also they are using this, but the cushions are different. Cushions are like sponges. I can say this procedure we are doing for sponges. Like we are cutting the sponges into small pieces, and the sponge consists of. We are not doing any surface modification on sponges because we
Okay,
are
sir.
adding the particles inside the sponges, so it is homogeneous throughout the material. It's not like on the surface. But for metals, you are coating on only on the surface, right?
Yes, sir. Yes, sir.
Yeah, so there is a difference like for this method. So this method is completely nutrient agar and dilution method. So we have bacterial suspensions. We are using the dilution, like we are diluting the bacteria inside the incubator, and then we are taking out the bacteria. We are pouring the solution on the sponge, and we are taking the sponge into the agar plate to check the antibacterial property. So that is a procedure to do this antibacterial property studies.
Okay.
You
Thank
know.
you, sir. Thank you so much, sir.
Yeah, but for metals it's different. Metals, they are not using dilution method. Like they're directly growing the bacteria on top of metals. Metals are different, but
Yes,
the
sir.
sponges are different. Yeah.
Okay. Thank you so much, sir, for explaining it.
Yeah, I think maybe I'm not expertise in the metals. I hope that whatever I know, because my lab people are working mostly on metals, that's why I can say all these things.
Okay, okay.
Yeah.
Thank you, sir. Thanks.
Yeah. Yeah. Okay. Any other questions you have?
So what are the percentages of castor oil and silver nanoparticles that you used?
Yeah, here I have a table here. I can show you that. Yeah, this is the percentage, which is almost this is a 30%. I can say like it's 12. Like totally it's 12. So it's one third of castor oil we are using instead of polyol. We reduce the content of polyol and we use the 3 grams of castor oil inside PU forms.
Okay, okay.
Okay. Yeah.
Hmm. Sir, and one more question. Sir, did you use the nanoparticles directly, or like did you synthesize these nanoparticles?
No, we purchased from these nanoparticles, and then we used these nanoparticles inside the method. We haven't synthesized this one.
Oh,
Yeah, we directly purchased from that. Maybe we can synthesize also, but we purchased, which is it's 100 nanometer particles. The diameter is nearly 100 nanometer. It varies from 50 to 100 nanometer for silver nanoparticles.
okay.
Yeah. Yeah. Is there any questions? Can I continue with the second part, like which is on piezoresistive sensors, which is completely different from this one? That's why I'm asking you.
Please continue, sir.
Yeah, okay. Okay, then let's talk about piezoresistive composites. So before going to that, there are piezoresistive elastomers. So it's a composite elastomer. So there is a difference. So generally in elastomer we have added the carbon nanotubes and carbon carbon black nanoparticles. In this study we used both like carbon nanotubes and also carbon black nanoparticles. So generally these elastomers we can sorry, actually these elastomers we can classify into two types. One is composites and also the pure elastomers. So here I'm talking about composites because it consists of carbon nanotubes and also the carbon nanoparticles is in uh, added inside the elastomer. So now I'm going to talk about physical parameters, not a materialistic, not on experiments, because it's completely on modeling part. Because my job here is to design a composite, composite which can act as a sensor. So here we can see the definition of piezoresistive sensor. One is when electric current is passed here. Let's say here we have CNTs, carbon nanotubes. So the electric current is passed through these nanoparticles. There is a gap between these two carbon nanotubes, which are called the gap. Here we can call it as a threshold gap. So it should be lies between 0.38 nanometer to 0.1 nanometer, like that. So based on the studies, we can say that. So with that gap, there is a tunneling is happening between the two nanoparticles, and then the electric current is passed through these nanoparticles and then flow through this. So due to this electric current, we can there is a change in resistance of a material. So based on change in resistance, we can know that how the material is going to fail in future, or what is the life of a material. We can take the we can use this material as a sensor. So like this we can use CNTs and also carbon black are spherical particles. We can see how we can design and how we can develop, like we can make these electrical paths conducted. Now here there are three things. One is interdistance between the particles, and there is a curvature. The change in resistance happening in three ways. One is interdistance, curvature, and three is through CNTs. So these are the nanotube resistances. So these three approaches, we can calculate the resistance of a piezoresistive, whole composite. So first thing, to achieve this piezoresistivity property is like junction gap widening or narrowing, which leads to variation of resistance, and then change in change in uh, change in curvature, change in resistivity caused by bending or axial deformation of the CNTs, and junction slippage. The third one is junction slippage here that induces the change of effective CNT segment length and delta L, and delta R is resistance, change in resistance. So using these three phenomenon, we can get the piezoresistivity of a composite inside the matrix. So here we are we have the conductivity versus CNT concentration. So when there is an increase in concentration, like when we increase the concentration of a nanoparticles, like whether it could be CNTs or carbon black, we can increase the we can increase the resistivity as well, piezoresistivity as well. So before percolation, we can call a percolation. Percolation is a percolation. We can say it won't allow the particle inside the one more particle. So which is called percolation. So before percolation and at percolation and after percolation. So we increase the particles, but we won't allow the one particle inside the other particle. There is a volume which is consists of volume of uh, you know excluded volume, so it won't include any other particle. So that's why we call that volume as an excluded volume of a two cylinders. When it comes to the CV, like I mean carbon black, it is spheres. So here we have cylinders because it's a carbon nanotubes. Here, so generally CNRS, if you know anyone about CNRS in France, so CNRS is kind of a DRDO in India. So CNRS are supplying the images. Here the NC is nothing but carbon black. In French they call as a noir carbon, which is called black carbon. So in French it's like different, like front back front, it goes around. So this is called carbon black, these round particles. These are CNTs. This is a TEM image, TEM image, transmission electron microscopy image, which was given by ICM and a division of CNRS. And then from these images, I'm going to create an RVE. RVE is nothing but representative volume element in Abacus, like in FEA. So using that like a representative volume element, like uh, which is a virtual design, like to for the sensor to analyze the whole design. It's a part of one design. We are not taking a whole model, we are taking a part of it model. So people who are in the audience, if you know, if you're aware of FEA, maybe you can understand what is it. So I'm saying in a layman term, like I'm not taking a whole model, I'm taking a small part of a model and making it as a representative volume element, which is called RVE. And then these are the SAX image, diffusion rayons excited angles, which means anisotropy. They are using SAX, which even I haven't done this because I got these results. So based on this, I use these parameters for my design. So this is a theory behind percolation excluded volume approach. So this was introduced by Jarre, which is volume of CNT divided by volume of excluded volume, which is nothing but 5. So here, finally, we wanted to calculate the conductivity of a whole composite. You can see how the CNTs are distributed and what is the like this large value of contact nodes. So we can see the contact nodes and the two distinct paths, black and red. Like we have the path. So this black and red shows that there is an electrical conductivity inside the matrix. So this represents there is a conductivity inside the matrix. So there is a lot of maths behind this, so I don't want to discuss with you. So because it's very deeper one. Like if you think about the angles, there are distance between two CNTs, and there is a if we consider the curves, there are a lot of geometrical parameters involved inside this percolation extruded volume approach. So over, like generally we can say, like this is also hyperelastic material. It is a composite. Inside composite there is a silver nanoparticles. So this hyperelastic material is EPDM, which is a rubber-like material. EPDM is a rubber kind of material. So we are using the matrix as an EPDM, and inside there is a carbon nanotubes. When we apply the load, which is nothing but the material is undergoes strain, so it change, there is a change of conducting paths. So the conducting paths will increase. So based on that, there is a piezoresistivity will occur, like based on the change in paths, as we already discussed, like in three different ways. There is a change of path. So uh, we can achieve the piezoresistivity based on the three different approaches we already discussed before. So here, after deforming, there is a change of conducting paths. We can analyze this displacement field of the matrix without CNT, and this is called decoupled approach. We are saying we are looking into the macroscopic level here. So this is an application in food industry, as I already mentioned. So this is a mechanism they are going to use. So here inside there is a piston. Piston ring is there here. So here this material is PTFE, and this ring we are using it as a EPDM ring. So this ring we are designing to act this ring as a sensor. So these are the results from cyclic response of this EPDM. So there is an electrode. So before me, there are few people who tested this EPDM mechanically, and I'm using that. I'm taking the data and designing a good piezoresistive sensor. So these are framework. First, I'm designing an RVS matrix and CNTs, and then finite element analysis of a composite, and then calculating the tunneling distance. And after calculating tunneling distance, there is a calculation like uh, we have calculating the uh, like uh, whole resistance of a composite. So then we are calculating the tunneling and then CNT resistance. Then we are evaluating the electrical resistance, and we are applying artificial neural networks. Like we are using AI, like machine learning techniques to get the information about whole model, and then we are doing a validation. So now, after creating a RVE, we have many geometrical parameters in order to get the resistance for a whole model. Um, if it is a school method, like we have a resistance, parallel resistance, series resistance. If it is a parallel, we can addition, and if it is series, it's a 1 by 20 plus 1. It's like 1 divided by. So this is a school method. But when it comes to it's not possible with this method analytically. So we use MATLAB to calculate, because there are a lot of information about CNTs, and there is a lot of equations that we need to solve using resistance calculator. So we have we come up with a function. We created a function to calculate the resistance for these materials. So here, this is an RVE I've created in MATLAB. So here we have electrode A and electrode B. We wanted to calculate the resistance when the current is passing through along these nanoparticles. We wanted to check the conducting paths as well using MATLAB. Here, there is a mechanical load here, and equivalent resistance we need to calculate. So this is a function we have in MATLAB we have created from my previous colleagues. Like they have created the MATLAB code, and we are modifying the MATLAB code because it's a big function. Now, thanks to ChatGPT, because we are using ChatGPT tool as well to make it easier, to make it fast. But before 2022, they developed this code with so many years, and then now we are developing, like after ChatGPT arriving, like we are using it in some areas, like they restricted, but we are allowed to use the ChatGPT to make this function more effective, and also to get an accurate resistance calculator, because it consists of so many functions inside the MATLAB. So there are nearly thousands of lines for each function. So we need to calculate all this function. We need to keep all together and then make this to calculate this resistance for a whole composite. Now, so I just want to give you a sample for 3 to 4, just to explain. Here we have 3 CNTs. So we are identifying paths here. Like here, the current is passing through here. This is one path, and this is 1A, 2 1, and 5 6. This is second path. So we can see here cylinder number and the means tunnel, and tunneling T is tunnel. Ij is from node I to J. So node I to J is from node here to here in one CNT, which is nano CNT, like say carbon nanotube. So we have many nodes like I, J, K, because to identify paths, we need to have a lot of information like here. So it should notice it should maintain the tunnel, it should maintain the gap between two, and it should take the van der Waals distance, which is threshold inside. So to calculate all these things, it's very tough to do with a single MATLAB code. It's very difficult. So we need so many functions to maintain these things in bulk. Like if I create an RV, and also we are using, we are coming up with good results nowadays here. So these paths we can see for only 3 CNTs we can see here. So these are the paths, and this is one path 864317, and this is other path current is flowing 865217. So like this we can see here in this. This is one path and this is second path. So like this we can calculate resistance for each path. Like this is a resistance, and there are internal resistance. There is a resistance inside, and there is a resistance due to the tunneling between two CNTs. There are two resistance we are calculating here, a whole for the whole composite. But the algorithm should identify the path also based on the distance between two, and it should represent where there is a tunneling, where there is not tunneling. It should identify that. So that is a very tough one. Like that's a very challenging one to do that. So now, so after the second the second important thing is like after application of strain. So if I wanted to apply a strain, so the change of paths are happening. So MATLAB code should identify these paths after change of strains, because the whole things are changing. So when we change of path, there is a change of electrical conductivity. So these are there. Based on that, the resistance of the whole composite will change. So it's a very tough task. This is just a few 4 CNTs just for you. I am like mentioning. I'm just showing like how it works. But when it comes to the real model, because we have clusters and we are using a workstation to calculate the resistance. Why? Because it consists of nearly 1 lakh CNTs in one RV, 1 lakh, nearly 50,000 CNTs, 1 lakh CNTs, and it's a real-time model. So for normal computing system, we can't do. So we are using clusters to Abacus clusters we are using, and we are using like a different, like we are using workstation to calculate the resistance in MATLAB. So this is just for your like reference how it is changing. So once after application of strain, once it is changing, there is a change in conductive paths. So the tunneling may happen or may not happen. So it depends on the strain, how the material is behaving. So based on that, the code should analyze the whole electrical conductivity of a whole paths, you know. So that's why we are introducing artificial neural networks as well to calculate the paths. So hope that we are achieving, but hope that we are achieving more results in future. So these are the graphic view. So here there is no conduction. So these are the conductivities happening between two CNTs. These are the node couples, and these are the paths. So here it consists of conducting path. Why? Because there is a difference between this CNT and this CNT consists of tunneling, but this CNT and this CNT don't have gap, because the gap is exceeding 1 nanometer, which is threshold value that we are fixing the threshold value as well. So based on that, we can know where the connecting paths and where is not connecting paths. So based on that, we change the design of our sensor. So and we change the carbon nano, like I mean, we increase the particles, we reduce the particles. So both we are doing. We are like playing. There are standardized, like there are methods to increase the particles to create an RV. Here this is a strain up to 18.5% increasing, but still low resistance. But when I increase the strain is nothing but the displacement. Like when I apply the displacement on an RVE, so there is a change. Like suppose the length of the matrix is 100. If I apply 20, so the strain is nearly the 20 divided by 100, which is change in length by original length. If you calculate that, the strain is 0.2%. I mean, we can say 2%, like 20% of strain, we can say. So 0.2 is a strain and 20% is a strain value. So like that, the strain is nearly 18.5. So there is no connecting path, but the strain is nearly 20.3, 22.2. There is a connecting path. And strains, if I increase strains, there is no connecting paths. So it is not depends on the amount of strain. The resistance is not depends on the amount of strain here. So which is a fact that we have come up with these sensors. So this is a path. And here we have electrical resistance versus strain. So there is sometimes some strain values. These are the strain: 25 mm displacement, 50 mm displacement, 75 mm, 100. But there is no there is an electrical connectivity. I mean, suppose if the current is passing here, suppose that there is no tunneling between one or two, so the electrical connectivity will stop here. There is no uh, path after this. Even if I design initially based on the strain values, sometimes there is a electrical connectivity will turn off. So that is representing here in this graph. So there is no conduction here. This means there is no conduction here. This is about it. Still we are going on, we are doing with carbon black nanoparticles, and we are doing with we are dealing with many nanoparticles like that I'm not going to discuss before, like maybe uh, in future we achieve that the result, then I'm going to publish it. And but for now I just wanted to give you an idea like how we are designing and what tools we are using. So here, uh, sometimes we may not achieve the conductivity also. So this is about it, about sensors. And if you, like now, I just want to give some start opportunities about if you have some good idea, you can just take that into the market and you can try. Nowadays, there are a lot of people who can train you. There are a lot of incubators, even in Anamacharya College. Also, I think there's an incubator, so supporting the college. So along these incubators, so there are some investors. They are like ready to give you a fund if you have any good idea. If you want to take that take your idea into the real time world, if you want to test your idea, you need to think about, yes, you may have an innovative idea, but you need to think about uh, whether it will work or not. That is a important task. So in 2023 to 2024, I work with one startup which is working on. Uh, we are using an AI, we are getting parts like 3D models of a human body using CT scans. So we come up with a new application which is very important for diagnosis to the doctors. So that time the startups are trying to get funds so these are the few areas like you can get a funds if you want to start a new startups. So BIRAC will give big grant, as you already know. So there is a startup in India, you can register, and when you are a student, like you can go with the idea, and then you will have TAA Global. So they are you can just participate in TAA Global, and once you have everything ready, maybe you can approach Chennai Angels. Like if you have Hyderabad, if it comes to Hyderabad Angels are there. So there are many opportunities. Maybe uh, you can go with, especially if you are working on bio areas. There are many opportunities. And thank you everyone for giving this opportunity. And merci beaucoup is a thank you in French. So if you have any queries, you can ask me on this. And thanks to Professor Venkatesh. Uh, and thanks to him who called me for this talk, who invited me for this talk. Hello.
Thank you, Chaitanya sir. Thank you very
Yeah.
much for the
Thank
wonderful
you.
insights into the session, especially that forms and then the scaffolds preparation, then even testing. Everything is super, sir. And
Yeah.
the session is open for discussion. Participants can unmute yourself and you can raise the questions, and our speaker will answer to the questions and get it clarified.
Hello.
Sir, myself Ajay Kumar, the coordinator for the FDP. I have one
Yes, sir.
question, sir, regarding the
Yes.
what are the different methods that we can carry out the antibacterial tests, sir?
Yes, sir. There are many methods, but as far as I know, we have used nutrient agar plate method, and it depends on the you know metals. Like if you work on metals, so you can also use nutrient agar method. But mine is we have micro dilution. I have used micro dilution. So as far as I know, because I'm more into the mechanical and uh, modeling stuff. So, but when I perform these antibacterial studies, so I know only two methods. One is microdilution and agar plate method. But there are many other methods also. Like maybe you can. It depends on materials. So like what material you're using. Like are you using metals or foams or?
Sir, metals, sir.
Yeah, so metals, if you are working on metals, you can work with nutrient agar plate method. So this is a standard method for metals. Nutrient agar plate method. Hello?
Yes, sir. Just I'm make a note of that. Thank you.
Yeah,
Thank you, sir.
okay.
Thank you for the clarification.
Okay. Okay.
Any other questions from the participants? Please rise and get it clarified.
रूम पचारे कपल को बिकिया भी नहीं हम रूम पचारे
Hello?
Participants, please raise the questions if you have any. Otherwise, you can use the chat box. Please post the question.
So, okay, sir. I think no questions, I guess.
Yes, sir. Thank you, sir. Thank you, Chaithanya, sir,
Okay.
for the wonderful
Okay, sir.
session.
Okay. Yeah, thank you so much, sir, for giving this opportunity, and thank you everyone for listening patiently. Sorry. And somebody asked me one question: what type of
Yes, sir.
nanoparticles you have used? Considered. It's silver nanoparticles, I think. Silver nanoparticle, but it's from a company called I forgot the company name. There are many companies in Bangalore, like they're making the nanoparticles. It's a silver-based one. So you can use many other nanoparticles also, like which is very low cost. But silver is a little bit expensive. I don't say it's very expensive, but little bit expensive. That's it. You can make your own nanoparticles also, graphene, but graphene you can't use for antibacterial property, I think so. But you have to check graphene. Maybe can you use on this form, because this is for uh, rehabilitation, right? Yeah. Okay, sir. Then thank you so much.
Thank you, sir.
Thank you, sir. Yeah. Somebody. Hello?
Sir, is it audible?
Yeah.
Yeah, audible,
It's
sir. Please
audible.
speak, sir.
So if you use zinc oxide nanoparticles, is it feasible for that test, sir? Can we use
Yes, sir. Zinc.
zinc oxide
Yeah, you can use, sir.
nanoparticles?
Actually, Yeah, actually, zinc oxide nanoparticles are good. We like zinc oxide is also alternatively you can use. It's a low cost compared to silver nanoparticles.
Sir,
It's a
if you
good.
don't mind, can you please tell me where we can purchase that nanoparticles, sir? I have been searching for the.
Actually, I because I performed this in 2018, sir. So we purchased from Bangalore. So I forgot the name. It's a
Sir,
standard.
Chaitanya sir, I would like to answer to that question
Okay, okay,
with your
sure, sir.
permission.
Yeah,
Yashwant
sir,
sir,
sure, sir.
you can search in SRL chemicals. Cisco Research Laboratory Chemicals is the one. If you want to have very good research material, you can check out in Sigma Aldrich or else Merck.
Sir, sorry, I remember Sigma Aldrich only. I purchased from Sigma Aldrich only.
Yeah.
Yeah. Thank you, sir. Actually, I forgot that name.
Yes, sir.
After yeah. Sigma
One
Aldrich
more
only,
is there,
sir.
sir. Alpha is there, which is means very good company. It's Indian version. It's a thermo scientific. We can refer even that also, sir, for materials.
Okay, sir. Thank you, sir.
Yes. Okay, sir.
Chaitanya
Then
sir, thank you, sir. I think no more questions from the participants.
okay, sir. Thank you, sir. Thank you very much, sir. And thanks to everyone. And see you. And yeah. Bye, sir.
Bye, sir.
Yes.
Regarding tomorrow session, the link will be shared through the WhatsApp. Please join us at tomorrow 6 p.m. Thank you all.
Okay. Thank you, sir. Thanks a lot.
Thank you.